Welcome to Gifted and Science and Technology Physics class. I'm NC Joshua, Propolinus Oracle. Today we'll be looking at upthrust and in holistic or holistically Archimedes Principle. Now, the experiment before us is a block held by a spring balance and is being immersed into a beaker containing a liquid, let's assume water. Now what happens the moment this block began to sink into the water or is being immersed into the water? We have a rise of water, and the rise in the level of the water results into this other container. So what we have here is the amount of water. This is water displaced. This is water displaced. So we are saying that when an object is immersed, now weight is acting up, there is an invisible force that is acting in the liquid. You have such an encounter when you take a drawer into the well. When the bucket or the drawer with tied to a rope is in the well, it appears to be lighter compared to when it is out of the water in the well. So it's appearing lighter because there is a force acting upward in the liquid. We call that force upthrust. So that force is acting upwards. We call it upthrust. It's a thrust. A thrust is a force, and because it's acting up, it is called upthrust. Now, the weight of this object is acting downwards, but the upthrust is acting upwards. Now, on this spring balance, there is what we call a tension. That's what we call tension. Now, this can be tension or the reading. Take note of this word. It is called tension or the reading on the spring balance. So you see it in questions. It will be asked, what is the reading? What is invariably telling you is, what is the tension? So what do we have here? The tension is acting upward. The upthrust is acting upward, but the weight is acting downwards. So the forces here are, the upward forces are, we have the tension plus the upthrust. These are the upward forces, is equal to the downward forces, which is just the weight. So another way I can show you is that tension plus upthrust, because they are acting in the same direction, tension up, upthrust up, minus weight, because it's going down, is equal 0. So therefore, tension plus upthrust is equal to weight. So an object immersed in a liquid exerts or experiences these three forces. What is one? The tension on the tension on the string that is holding the object. Two, the weight of the object. And three, the upthrust. Now, what about these three forces? Tension is an example of contact force. Forces can either be contact or feed forces. Contact or non-contact. Non-contact are called feed forces. So tension is an example of a contact force. Upthrust is an example of a contact force, but weight is an example of a feed force. So all these, take note of these, all these are examples of forces and how we classify them. Now, what is this mass or the weight of the water displaced? It is said that the mass or the weight of the water displaced, the weight of the water displaced or the mass of the water displaced equal the upthrust. So upthrust is equals the weight of water displaced, the weight of liquid displaced. Let's use liquid for it. Liquid displaced. So upthrust is equals mg. That's upthrust. And we know that upthrust is equals what is mass? If if density equals mass over volume, therefore mass is equals density times volume. So it means therefore what is upthrust? Upthrust is now equals in place of mass, I will put density times volume then times G. This is upthrust. Now mind you, very important. How did we get this density? Density of a solid equals mass of a solid over volume of the solid. What is now mass of the solid? Mass of the solid will be equals, density equals mass over volume. Now, what about this? We said equals density times volume times G. Now, this is the density of the liquid and this is the volume of the solid. Take note of this. Upthrust equals the density of the liquid times the volume of the solid times G. I want to say something concerning the volume of the solid. Archimedes said if a body is totally or partially immersed in a liquid, it experiences an upthrust which is equal to the weight of water displaced or weight of the liquid displaced. So it's because of what Archimedes said. That's why I said upthrust equals weight of the liquid displaced. So if Archimedes says, or Archimedes says that the volume, if the object is totally immersed or partially immersed, so it means I can still say that if half of the object was immersed, if half of the volume of the object was immersed, it means upthrust will be equals density of the liquid times half the volume of the solid times G. This will not be if it's half of it. What about if it's two-thirds of the liquid that was immersed? If it's two-thirds, it means upthrust will be equals density of the liquid times 2 over 3 the volume of the solid times G. So we must be conscious of the volume of the solid that is being immersed in the liquid. For instance, the liquid, this volume, this solid is immersed totally. So the whole volume will be used. That's something like this. But if it's half of its volume that is immersed, if it's half of the volume that's immersed, we will not know what fraction of its volume was immersed, and that ought to be taken into consideration. Thank you. Now, imagine a case where we are now asked to find the reading in such a scenario. I'll be showing you questions as regards all of this. Now, imagine a case where we want to find the reading. Now, remember, we said that tension is equals tension plus upthrust equals weight. So tension, which is the reading, equals weight minus upthrust. So tension is equals, what is weight? Weight is mg minus what is upthrust? Rho vg. So tension equals, what is common? G is common, open bracket, mass minus density times volume. Remember, density of the liquid and volume of the solid. And if this volume varies in its fraction, depending on what is immersed, you have to take it to be a coefficient before multiplying by the volume. So this can be a formula to solve for tension or for reading as regards upthrust. Now we'll be looking at questions concerning calculations about upthrust and Archimedes principle. Question number 1 says, a balloon whose volume 300 meters cubed is filled with hydrogen of density 1.3 kilogram per meters cube. Find the upthrust. What is upthrust? Upthrust equals rho Vg. So upthrust equals density of the fluid, which is equal to 1.3 times, what is the volume? 300 times G here is 10. So upthrust is equals, check this up, you have this, then you have 13 times 6, 3 times 6 9, then 300. So it's 3,900 Newton. That becomes the answer to question number 1. Question number 2 says, an object weighs 22 kg in water. Very nice question. An object weighs 22 kg in water and 30 kg in air. What is the upthrust of the liquid? What is the upthrust of the liquid on the object? Now, you realize that an object will weigh more when it is outside a liquid, but when put into a liquid, it is lighter than when it is in air. So we said the reason is because there's an invisible force that is acting upwards, and that force is called upthrust. So it means that upthrust for number 2, upthrust is equals weight in air minus weight in liquid. Now the liquid we are dealing with here is water, so becomes weight in water. Please take note of this. If it was another liquid, it would have been upthrust is equal to weight in air minus weight in that liquid. So this is called upthrust in liquid, while this is called upthrust in water. So now what about if it was now relative density? If it was relative density, I was asked to calculate it for, it would have been relative density equals upthrust in liquid over upthrust in water, which is equal to weight in air minus weight in liquid over weight in air minus weight in water. Take note of this. This is very, very important. Now, I want to say something here before I solve the question. This is if the object was immersed in a liquid and after then, or immersed in water and after then in a liquid, or immersed in a liquid after then in water. We're not saying that the weight of that object in the liquid, there is a weight of that object in water, and there is a weight of that object in air. So, upthrust in water is weight in air minus weight in water. Upthrust in liquid is weight in air minus weight in liquid. But relative density in terms of upthrust is upthrust in liquid over upthrust in water, which equals weight in air, because upthrust in liquid is weight in air minus weight in liquid, while upthrust in water is weight in air minus weight in water. What about if it was just in air and in water? No additional liquid. It will be relative density is equals weight in air over weight in air minus weight in water. Take note of this. This is when it's involving just one liquid, and the liquid we're using here is water. Weight in air over weight in air minus weight in water. But if it involves two liquids, it will be weight in air minus weight in liquid over weight in air minus weight in water. That's relative density. Now, what is our question asking us? Let's go back to our question. Our question tells us the weight in water and the weight in air. The question is now asking us to find upthrust. So to solve that, we're going to be using weight in air minus weight in water. So that becomes, what is the weight in air? Upthrust is what we are looking for. Upthrust is equals, what is weight in air? Weight in air is 30. So that becomes 300 Newton minus, remember they gave us 30 kg times 10, that's 300 Newton. Then this one is 22 times 10 minus 220 Newton. So upthrust will now be equal to 80 Newton. That's the answer to that question. But if it was calculate the relative density, it would have been weight in air over weight in air minus weight in water. Very important that these things are noted. Now let's look at question number 3. It says a cube of size 0.1 meters hangs freely from a string, full stop. What is the upthrust on the cube when totally immersed in water? The liquid is water. So upthrust is equals rho Vg. Now remember, what was given us is just the side of the cube, 0.1 meters. And we know that volume is equals L raised to power 3. So it equals 0.1 raised to power 3 is equals 0.001 meters cube. That is the volume. So now what is now our upthrust? Upthrust equals density of water. Now remember, I'm working with meters. So I will be using 1,000 kilogram per meters cube times volume will be 0.001, then times 10. G is 10. So 1, 2, 3, we take off 1, 2, 3, I'm left with just 1. So upthrust equals 10 Newton. That becomes the answer. Upthrust is a force, and the SI unit for upthrust is Newton. Now let's look at question number 4. Question number 4 says an object weighs 8 newtons in air is partially immersed in water. It displays, look at this question very well. It displays water of mass 0.4 kg. What is the upthrust? Remember when we started the class, we said upthrust, according to Archimedes principle, says that when a body is partially or totally immersed in a fluid, it experiences an upthrust which is equal to the weight or the mass of the fluid displaced. So now, when this object was immersed partially in water, it displaces water of mass 0.3 kg. So it means the mass of water displaced is the upthrust. So to this question number 4, I would just say upthrust is equals mass of water displaced. That's upthrust. So therefore, upthrust equals, what's the mass of water displaced? Is 0.3 kg, which equals 0.3 times 10. Upthrust equals 3 Newton. Very tricky question. The answer is in the question. Why? Because the mass of water displaced is the upthrust in water. Thank you. Now let's look at question number 5. Question number 5 says a block of material of volume 20 cm cube and density 2.5 gram per cm cube is suspended from a spring balance with half of its volume. All these things are important. Half of its volume, half of the volume of the block immersed in water. What is the reading of the spring balance? Remember, I told you that the reading of the spring balance is the tension of the spring balance. Now, what are the forces we said? What are the forces? What forces will be noticed, or what are the forces present when an object is tied to a spring balance and is now immersed in a container containing a liquid? It's just something like this. We have a sketch of a spring balance having an object, and this object is immersed in a liquid. Now the object is partially immersed, so some side of the object is above the liquid, but if it was totally immersed, it would have been all inside the liquid. So it was half of the object that was immersed. Look at it. Half the volume of the block was immersed. So now we have weight acting downwards. We have upthrust acting upwards. Then we said tension is the reading and it's acting upward. So we now said the forces are upward forces equals downward forces. What are the upward forces? Upthrust plus tension. Upthrust plus tension equals weight. Now remember we said what is tension, because tension is the reading. Tension will now be equals weight minus upthrust. Now what is tension? Remember weight is mass times gravity minus upthrust is rho Vg. We continue by saying T, which is the tension, and the reading is equal to, what is common here is G, open bracket, mass minus density times V. Now remember that it's half of the volume that is immersed. So I will come here and make here density dot 1 over 2 times V, because it is half of the volume. I will not just make it V, I will make it 1 over V. Why? Because half of the volume was immersed. Remember, this is volume of the solid and density of the liquid. Now, what is the mass of this block? We do not know the mass of the block, but the volume of the block was given us and the density of the block was given us. So I can look for the mass of the block. Where mass of the block, where mass, mass of the block, where mass of the block is equal to density times volume. Mass is density times volume. So I will say therefore mass of block is equals density of block is 2.5 times volume of block is 20. So the mass of the block will be equal to 50 grams, not 50 kilograms, 50 grams. Remember, we are using grams per cm cube. So, therefore, what is now tension, which is reading? Tension, which is reading, is equal to G, open bracket, 50 minus density of water is 1 gram per cm cube or 1000 kilogram per meters cube. So in this case, I'll be using 1 gram per cm cube because my questions is giving me in cm cube. My parameters were giving me in cm cube. So 1 times 1 over 2 times the volume of the solid is 20 times 20. Now, this cancel this, that's 10. So, tension, which is reading, is G open bracket 50 minus 10. Have you noticed that I did not convert my G to 10 meters per second squared because I'm working with centimeter. So I have to hold my G. I'm working with gram per cm cube. I have to hold my G. I will tell you why. Because in converting this G to 10, it won't work if it's not in kilogram per meters cube or just kilogram. So if it's in gram, there is no need to convert. Again, I will just retain my G. So my T is equal to 40 grams. My G, my T, which is my tension, is equal to 40 grams. I cannot convert this to kilogram. Converting this to kilogram will be dividing this by 4, which is equal to 0.04 kilogram. Convert it to Newton, which will be equal to 0.4 Newton. Very, very important you understand this. So if the question was asking me to express it in kilogram, it will be this. If it's to Newton, it will be this. But the answer, as per what this question holds, is in grams. So it's 40 grams. That becomes the answer to this question. Thank you.